Hi, my name is Nathan, and in this video, I'll be presenting my video pitch for Assessment Task 3. On this slide, I provided a screenshot showing me running the question allocation program. From the 5 questions randomly generated, I've chosen to discuss the following 3. Quiz 5 Question 2, Quiz 3 Question 1, and Quiz 8 Question 2. The first question I will discuss is Quiz 5 Question 2. For this question, both statements are true. In statement 1, the first observation shows A and B having an equal probability, whereas the second observation shows that A only has a 5% chance of occurring, whilst B has a 95% chance. When comparing these two observations, we can see that the first observation contains more information since the entropy or uncertainty of the outcome is greater. Therefore, this statement is true. Dr. Jun Lee provided a great analogy to explain this solution. It went as follows. Imagine you were in an exam and had one opportunity to cheat off someone, but there are 2 questions which you do not know the answer to. For the first question, you are 50% sure that your answer is correct, and for the second, you are 95% sure. Which question would you rather cheat on? Obviously, you would rather cheat on the question that you are only 50% sure of, since there is a higher degree of uncertainty. In statement 2, it is observed that A has a 0% chance of occurring, whilst B has a 100% chance. This observation contains no information because there is no uncertainty in the outcome. B has a 100% probability. Therefore, this statement is also true. The next question I will be discussing is Quiz 3, Question 1. For this question, the second answer is correct. In a linear regression model, predictions are made based on the relationship between attributes. Therefore, each attribute is given a parameter which represents the weight, or the amount that the prediction increases by, for every unit increase in that attribute. In the linear equation y equals mx plus b, the attribute weight is equivalent to m, also known as the gradient. Furthermore, an additional parameter is needed for the constant offset. In the linear equation y equals mx plus b, the constant offset is equivalent to b, also known as the y-intercept. The constant offset represents the value of the dependent variable y when all independent variables x are equal to 0. Furthermore, without the constant offset parameter, all potential regression lines will be forced to cross through the origin, thus severely limiting the range of potential lines. To answer the question, since the model is taking an input of 10 data attributes, there will be 10 parameters, plus the constant offset parameter, totaling to 11. The other 2 answers are incorrect because the training sample size should not be taken into account when making predictions with a linear regression model. Lastly, I will discuss Quiz 8, Question 2. For this question, the first answer is correct. The reason why is because in an ensemble method, only one set of training data is used, from which all individual classifiers are constructed. More specifically, pseudo-training sets are randomly redrawn from the original training data, and are then used to train weak predictors. These pseudo-training sets are not independent. Essentially, the fact that each Bayes classifier is selected with respect to the same criteria inherently links one classifier with the others. Therefore, the so-learned classifiers are not independent. No matter how many times you resample the original training set, the pseudo-training sets will still be dependent. This concludes my video pitch. Thank you for listening.